From wasteland to seafood paradise. How China turned the desert into an ocean. Picture this, a vast, unforgiving desert stretching endlessly under a scorching sun. Temperatures that could fry an egg on the sand. No coastline for over 1,000 miles. This is the last place on Earth you'd expect to find salmon swimming, shrimp thriving, or crabs crawling. Yet against all logic and conventional wisdom, China has invested more than $820 million to accomplish something that sounds like science fiction, raising millions of fish and crustaceans in one of the planet's harshest, driest environments. Welcome to Xinjiang, a landlocked region in northwest China that sits more than 1,600 kilometers from the nearest ocean. For centuries, this territory has been synonymous with isolation, extreme temperatures, and barren soil. 10 years ago, if you'd suggested that premium seafood could be commercially farmed here, you would have been laughed out of the room. Today, Chinese engineers and farmers have transformed that impossible dream into a thriving reality that's reshaping the future of global aquaculture. High-end delicacies that were once exclusive to coastal metropolises, Norwegian-quality salmon, succulent white shrimp, tiger prawns, and blue crabs, are now being harvested from the saline alkali lands of China's desert interior. This isn't a small-scale experiment. We're talking about an industrial revolution in food production that challenges everything we thought we knew about where and how seafood can be cultivated. So how exactly did Chinese scientists and entrepreneurs pull off this seemingly impossible feat? Can fish raised in desert conditions truly match the quality of their ocean-born counterparts? And what does this breakthrough mean for the future of global food security? If you're fascinated by stories of human ingenuity pushing the boundaries of what's possible, make sure to subscribe and hit the notification bell. You won't want to miss what comes next. Let's dive deep into today's story. The unlikely setting. Xinjiang sprawls across approximately 1.66 million square kilometers in the heart of the Eurasian landmass, representing roughly 1/6 of China's total territory. The landscape is a geological puzzle of dramatic contrasts: towering mountain ranges, expansive basins, high-altitude plateaus, and seemingly endless stretches of desert. On paper, it reads like a textbook example of where seafood farming absolutely should not happen. And honestly, on the surface, Xinjiang appears to be nature's way of saying nothing delicate can survive here. The region experiences some of the most punishing climatic extremes imaginable. During summer months, temperatures can rocket to 45 degrees Celsius, hot enough to make the air shimmer with heat waves. Come winter, that same thermometer can plunge to -30 degrees Celsius, creating conditions harsh enough to freeze exposed skin in minutes. The precipitation patterns are equally discouraging. Annual rainfall barely reaches 200 millimeters in most areas, while evaporation rates soar between 2,000 and 3,000 millimeters per year. That's a deficit that would bankrupt any water budget. Add to this equation the fact that most of Xinjiang's terrain consists of saline alkali soil, ground so saturated with salt and minerals that traditional crops struggle to take root. And you have what agricultural experts would classify as essentially dead land for food production. From every conventional agricultural perspective, attempting to raise delicate aquatic species here makes about as much sense as opening an ice cream shop in a volcano. But here's where the story takes an unexpected turn. Those very characteristics that made Xinjiang seem impossible for seafood farming? Chinese scientists looked at them and saw not obstacles, but hidden opportunities, turning weakness into strength. Xinjiang contains more than 100 million mu of saline alkali land. That's roughly 16% of all such terrain in China. For decades, this acreage was written off as agriculturally worthless. Farmers couldn't grow rice, wheat, or most vegetables in soil so heavily saturated with minerals. It seemed like a permanent liability on the nation's agricultural balance sheet. Then researchers made a fascinating discovery. When they analyzed the mineral composition of Xinjiang's groundwater and saline soil, they found something remarkable. These supposedly useless lands were rich in potassium, calcium, magnesium, and other elements. Even more intriguing, the mineral profile closely mimicked the chemical composition of natural seawater. That observation sparked an audacious question. Could we transform this mineral-rich groundwater into artificial seawater through precise engineering? The answer, as it turned out, was yes. Through careful technical adjustments and precise proportioning, Chinese scientists successfully developed methods to convert local groundwater into synthetic seawater that could support marine and brackish water species. At salmon breeding facilities in places like Nilka County, technicians now fine-tune just a handful of water quality parameters to recreate the exact environmental conditions these fish need to thrive. But wait, there's more to this story. Xinjiang's seemingly hostile climate actually conceals some unexpected advantages for aquaculture, particularly for cold water species like salmon. Although the region sits far from any ocean, it's surrounded by the Tian Shan mountain range, which acts as a massive barrier that traps and accumulates atmospheric moisture. Many of the breeding facilities are strategically positioned in basin terrain, where even minimal rainfall collects and can be efficiently utilized, rather than immediately evaporating or running off. More crucially, those surrounding mountains are perpetually snow-capped, creating a natural water tower. Year after year, glacial melt and snow melt from the peaks provide a consistent, reliable water supply. Rivers like the Tarim River become natural reservoirs that feed the region's burgeoning aquaculture industry with pristine, mineral-rich cold water. In other words, what appeared to be a desert wasteland was actually an untapped aquatic resource waiting to be unlocked. Why bother? The crisis driving innovation. At this point, you might be wondering, China has a coastline spanning more than 4.7 million square kilometers. The country is bordered by the Yellow Sea, the East China Sea, and the South China Sea. Why would anyone invest hundreds of millions of dollars to farm seafood in one of the most logistically challenging locations imaginable? The answer lies in a convergence of environmental pressures and economic realities that are reshaping global food production. China's traditional seafood farming industry has been hitting some serious roadblocks. Land availability for coastal aquaculture has become increasingly scarce as urban development consumes shoreline real estate. Ecological concerns about coastal farming's environmental impact have grown more urgent. Perhaps most telling, freshwater aquaculture, once a robust sector, has been in steady decline. Consider these official statistics. In 2018, China's freshwater aquaculture area covered approximately 28 million mu of surface. By 2023, that figure had contracted to less than 25 million mu, a consistent downward trend spanning 5 consecutive years. Meanwhile, the world's oceans are facing mounting challenges of their own. Plastic pollution has reached crisis levels. Humanity consumes more than 500 million plastic bottles annually, and these petroleum-based products can persist in marine environments for centuries, breaking down into microplastics that infiltrate the food chain. Ocean acidification, overfishing, and climate change are adding additional stress to wild fish populations and marine ecosystems. These converging pressures forced Chinese policymakers and entrepreneurs to ask a revolutionary question. What if we could produce fresh, high-quality seafood without depending on the ocean at all? The birth of desert aquaculture. In February 2014, a pioneering Chinese seafood company launched an ambitious salmon farming project at the base of the Tian Shan Mountains. This wasn't some small pilot program. By May 2016, the facility had moved from concept to full commercial production, backed by a staggering investment of nearly $260 million. The scale is genuinely breathtaking. The operation encompasses 100 square kilometers of cold water aquaculture surface, an area roughly the size of Paris. The complex includes 3 separate salmon farming zones, 3 primary processing facilities, and 2 specialized deep processing plants dedicated to preparing the fish for retail and restaurant markets. The technological sophistication deployed here would impress any Silicon Valley entrepreneur. The farms utilize massive circular ecological cages, some with diameters stretching dozens of meters. While the cage surfaces float on the water's surface, the underwater operations are monitored by robotic systems weighing more than 400 kilograms. These submersible robots are equipped with optical cameras and sonar equipment that monitor water quality and fish behavior 24 hours a day, 7 days a week. The goal? Ensuring every salmon grows in optimal conditions, with water temperature, oxygen levels, and pH precisely calibrated to maximize health and growth. The company has developed and patented more than 60 core technologies specifically designed for large-scale, surface-level, cold water fish farming. As of 2023, Xinjiang's annual salmon output had reached 3,000 tons, accounting for nearly 20% of China's total domestic salmon production. That's a market share that would have seemed inconceivable a decade earlier, but salmon was just the beginning. Expanding the desert menu. Encouraged by the success of salmon farming, Chinese aquaculture companies set their sights on diversifying the range of species that could thrive in Xinjiang's unique environment. In 2021, an even more ambitious project broke ground in Aral City, a white shrimp farming operation backed by $350 million in investment. The facility, covering 1,000 acres, looks like something from a futuristic agricultural complex. Rows of azure blue breeding pools are arranged in precise geometric patterns, each covered with translucent solar panels that regulate temperature while generating renewable energy. Surrounding the pools is a comprehensive intelligent monitoring network that tracks every variable that might affect shrimp health and growth. The artificial ocean system employed here represents the cutting edge of aquaculture technology. 18 different parameters, including water temperature, pH balance, salinity, dissolved oxygen, and mineral composition, are continuously monitored through automated sensors. Computer systems make real-time adjustments to maintain perfect conditions, something that would be impossible to achieve through manual management alone. Sustainability is built into the design. The facility has achieved remarkable water recycling efficiency. After passing through microbial filtration and purification systems, the water can be reused repeatedly, achieving water savings of more than 70% compared to conventional farming methods. In a water-scarce region, this efficiency isn't just economically smart, it's environmentally essential. They've even implemented three-dimensional multi-species farming systems. At the bottom of each shrimp pond, a species of algae-eating fish called weed ear fish, sometimes referred to as scavengers, is also cultivated. These bottom dwellers consume shrimp waste, naturally maintaining water quality while providing an additional harvestable product. It's an elegant closed-loop system that mimics natural ecosystem dynamics. The numbers tell an impressive story. In 2022, this single facility released 1.4 million white shrimp juveniles and harvested more than 15 tons of market-ready product. The stocking density is carefully controlled, no more than 120 shrimp per square meter, significantly lower than the cramped conditions typical of coastal high-density operations. This spacious approach has tangible benefits. With ample room to move and access to scientifically formulated feed, the shrimp grow larger and develop firmer, more flavorful meat. The average size runs about 50 to 60 individuals per kilogram, noticeably bigger than typical farmed shrimp. By the end of 2024, Xinjiang's saline alkali water aquaculture area had exceeded 10,000 acres, encompassing more than a dozen species, including tilapia, California bass, blue crabs, and various shrimp varieties. Total annual production had surpassed 6,000 tons, and the trajectory continues upward. The taste test, desert versus ocean. Skeptics had a reasonable question. Sure, you can grow seafood in the desert, but can it possibly match the quality of ocean-caught or traditionally farmed marine products? In early 2024, an event in Beijing provided a fascinating answer. Organizers arranged a blind tasting competition featuring two salmon samples. One had been farmed in Xinjiang's desert facilities. The other came from Norway, universally recognized as producing some of the world's finest salmon. Hundreds of participants sampled both products without knowing which was which. They were asked to evaluate texture, flavor, fat distribution, and overall eating experience, then indicate their preference. After compiling the scoring data, the results surprised even the organizers. 67% of tasters preferred the Xinjiang salmon. Participants consistently described it as having firmer texture, more evenly distributed fat marbling, and a smoother, more delicate taste profile. This outcome wasn't a fluke. It's a direct result of Xinjiang's unique environmental advantages. Salmon are cold water fish that thrive in temperatures below 15 degrees Celsius. The glacial meltwater flowing from the Tian Shan Mountains maintains temperatures between 8 and 12 degrees Celsius year-round, essentially a natural refrigerated environment perfectly suited for salmon. This pristine mountain water is also rich in dissolved minerals and oxygen, promoting healthy, vigorous growth. The breeding density in Xinjiang facilities is approximately 30% lower than typical ocean pen operations, giving each fish more space to exercise and develop muscle tone. The abundant sunshine at high altitude promotes robust algae growth in the breeding waters, providing natural supplementary nutrition beyond formulated feed. These factors combine to produce salmon with well-developed musculature, optimally distributed oils, and flesh that displays the ideal orange-red coloration prized by chefs. The taste is fresh and tender without any oily heaviness, with a clean finish that lingers pleasantly on the palate. Beyond superior taste, Xinjiang salmon offers another critical advantage: safety. Because these farms are located inland, they're completely isolated from marine pollution sources. There's no risk of microplastic contamination, no concern about mercury or other heavy metals that accumulate in ocean fish. The entire production system uses strictly tested and filtered groundwater. Every stage, from water quality to feed composition to environmental management, is subject to rigorous quality controls, ensuring that the final product is not only delicious, but demonstrably safe for consumption. Conquering the logistics challenge. Well, that's a story in itself. Growing exceptional seafood is one achievement, but, getting it fresh to consumers thousands of kilometers away is another challenge entirely. Just look at a map of China, and the scale of the problem becomes immediately apparent. The distance from Xinjiang to Beijing is over 2,000 kilometers in a straight line, and Xinjiang to Shanghai approaches 4,000 kilometers. Seafood is notoriously perishable, with strict requirements for temperature, humidity, and handling. There's an old saying in the industry: freshness decreases by 5% every hour. Without a sophisticated cold chain logistics system, seafood shipped from Xinjiang to eastern coastal cities could lose more than 80% of its freshness before arriving at market. Solving this problem required partnership between Xinjiang aquaculture companies and China's major logistics providers. In August 2023, ZTO Cold Chain established a dedicated operations center in Xinjiang. SF Express, China Southern Airlines, and other carriers soon followed, collaborating to build what they call a blue logistics channel, specialized infrastructure for moving perishable seafood products at optimal speed and temperature. Today, premium products like Xinjiang salmon and white shrimp can be airlifted to provincial capitals nationwide within 36 hours from harvest. The preservation protocol involves a 4-layer system, pre-cooling immediately after processing, vacuum-sealed packaging to prevent oxidation, strategic placement of medical-grade ice packs, and finally enclosure in professional-grade insulated containers. Throughout the journey, temperatures are maintained between 0 and 4 degrees Celsius, the optimal range for preserving seafood quality. This logistics breakthrough means that, Well, consumers in Shanghai, Guangzhou, or Shenzhen can enjoy Xinjiang seafood that's actually fresher than products that spent days on a fishing boat before reaching port. Looking forward, from experiment to industry. With production and distribution challenges solved, Xinjiang's aquaculture sector has achieved what business analysts call closed-loop capability: seamless integration from breeding through processing, transportation, and final sale. By 2024, Xinjiang's total aquatic product output exceeded 196,500 tons. That's not a projection, it's actual production volume, representing significant year-over-year growth. Current forecasts suggest this figure could reach 250,000 tons by 2025. The species diversity continues to expand. Alongside salmon and white shrimp, Xinjiang now produces blue crabs, crayfish, giant river prawns, sea bass, trout, and more. Each variety represents years of research into adapting species to local conditions and developing specialized breeding protocols. To further boost capacity, regional authorities have announced plans for an additional $210 million in investment, focused on expanding surface cage farming areas and introducing new species to the production roster. The goal is explicit position Xinjiang as a major contributor to national aquatic product output, not just a regional curiosity. The export potential is equally promising. As early as 2023, Xinjiang-produced seafood represented 20% of China's domestic production, a substantial market position. But increasingly, international markets are taking notice. Russia and Malaysia have emerged as significant export destinations. In 2024, premium categories like king crab, trout, and haddock saw substantial increases in export volume to Russia. Trout exports alone reached 5,000 tons, more than quadruple the previous year's figure. If current growth trends continue, projections suggest this could surge to 21,000 tons by 2025, explosive growth by any measure. A blueprint for global replication? Perhaps the most exciting implication of Xinjiang's success is its potential scalability. Could this model be replicated elsewhere? The answer appears to be a resounding yes. China possesses more than 1.5 billion mu of saline alkali land, distributed primarily across Xinjiang, Inner Mongolia, Gansu, Qinghai, and other northwestern regions. Historically, these territories were dismissed as agricultural dead zones, land with no productive future. The Xinjiang aquaculture breakthrough has reframed that perspective entirely. What was once considered wasteland could become what industry insiders are calling a blue granary, a new frontier for sustainable food production. Several Chinese regions are already moving to replicate Xinjiang's success. Ulaanbaatar City in Inner Mongolia is developing its own salmon breeding complex. Wuwei City in Gansu Province is experimenting with white shrimp cultivation in local saline alkali land. Zhongwei City in Ningxia has identified an even more innovative approach, leveraging the region's abundant geothermal resources to farm tropical fish species, potentially achieving year-round production in a cold climate. According to forecasts from China's Ministry of Agriculture and Rural Affairs, by 2030, the nation's saline alkali land dedicated to seafood farming could exceed 5 million mu, generating an annual output value exceeding 100 billion yuan. That's not incremental growth. It's the creation of an entirely new agricultural sector from terrain previously considered worthless. The bigger picture here is, when you step back from the technical details, what we're witnessing in Xinjiang is something more profound than just clever fish farming. It's a case study in creative problem solving, in refusing to accept that limitations are permanent. For millennia, human civilization has been constrained by geography. If you wanted seafood, you needed access to oceans, seas, or major river systems. Landlocked populations made do with whatever freshwater species they could cultivate or preserved products that traveled poorly. Premium seafood was a luxury reserved for coastal elites. Xinjiang's aquaculture revolution challenges those ancient assumptions. It demonstrates that with sufficient ingenuity, technological sophistication, and willingness to invest, we can fundamentally alter the relationship between geography and food production. This matters for several reasons. First, global population continues to grow, projected to reach nearly 10 billion by 2050. Feeding that population will require dramatically increased food production, but traditional agricultural land is already heavily utilized. Finding ways to make previously unusable land productive isn't just innovative, it's increasingly necessary. Second, as climate change disrupts traditional agricultural patterns and ocean ecosystems face mounting stress, the ability to produce food in controlled, sustainable inland environments becomes a strategic asset. Xinjiang's model offers resilience against the uncertainties of both marine and terrestrial agriculture. Third, there's a food security dimension. Nations that can produce diverse, high-quality protein sources domestically, regardless of coastal access, gain independence from international supply chains that can be disrupted by geopolitics, pandemics, or natural disasters. Finally, there's an environmental argument. Properly managed inland aquaculture systems can be more sustainable than traditional ocean farming or wild fishing. Water is recycled efficiently. Feed can be precisely calibrated to minimize waste. Pollution sources are controlled. Impact on wild ecosystems is minimal. None of this means Xinjiang's approach is perfect or without challenges. Energy consumption for maintaining artificial seawater systems is significant. The upfront capital investment is substantial, potentially prohibitive for developing economies.